Hello everybody, my name is Code Blue and welcome back to another Code Blue tutorial. Now in this video we're going to be learning about FFT and how to make a visualizer for sound inside of GMOD. Now you have to excuse me because I am a bit ill. Someone requested this tutorial and I promised that I would make it for them, which is why I'm making this tutorial. Now if you don't really have an interest in sound or visualization at all, then this video isn't for you. But if you do, then I expect you to have at least a very basic understanding of sound, which you should have learned in school. So most of you would be okay with that. But first of all, I want to go ahead and I want to explain how sound is represented. So I have FL Studio here. And what I'm going to do is I'm going to play a song. Okay, now if I open this up and we examine the frequencies on it, okay? Now don't worry about knowing what this does, but what you'll notice is while I play the song, this thing here will change color, okay? Where it's this color, for example, the color it is now, that means that there's no sound playing in that frequency. And the more orange that it is, the more dominant or the louder that frequency is. So let's say that you was playing only the bass part of a song, okay? You would notice that only this lower part here would be changing, okay? Because this, as you can see here, is the low bass region. If you was playing something like cymbals, like crash or something, then you would notice them up here in the upper mid to treble because, you know, it's a high frequency instrument. So what I'm going to do is I'm going to actually go ahead and just do some amazing EQing. And I'm going to leave just some of the low end in there and show you what it sounds like now. 1 second. There we go. And you can see that the colors up here are barely noticeable now. But, of course, the colors that are down here, if I press play, still noticeable, right? And, of course, if we boost that, you see it, okay? And of course, that applies to everything. So if I do the same for the highs, and I'll just quickly do the same for the mids. Okay, and essentially what you can do using FTT inside of Garry's Mod is imagine sampling all of those frequencies at once and understanding how loud each frequency is, okay? So what I could do is in Gmod, let's say that if it's no color like this, it's a 0, and if it's bright orange, it's a 1, okay? If I'm playing this now, let me go ahead and remove all of these completely. Let's say I press play, okay? If I got a sample by here, it would pretty much be like 0.1. It's a very minor thing. If I got a sample here, it would be close to a 1 because it's much more dominant, right? That's essentially FTT. And we can use that to visualize our audio. So if you wanted something to, you know, bounce to the bass, then we could just sample the bass part of some audio and make something happen to that. So I'm not going to go any further into that as it might bore a lot of you. But what I will do is I will go into my Lua folder and I will create a new Lua file in here. I'll call it visualizer. Nice spelling me. Visualizer. Okay. You could make this an add-on. I'm not going to bother right now for simplicity reasons. So now that we have this here, what we're going to do is we're going to go ahead and we're going to want to first, sorry, excuse me. We're going to first want to go ahead and make an audio channel. So to do that, what we're going to do is we're first going to make a local variable, and we'll call it player, for example. Actually, no, that's a bit confusing. We'll call it audio source, okay? And we'll actually set it to nil. The only reason I'm doing this is to actually define the variable in this scope, so we can access it outside of the next part of what we're going to do, which is actually going to make the station. So what we're going to do is we're going to do sound.play file, okay? I can spell that is play file. Now, for those of you who haven't used sound.play file, I think that's an MP3 in my thing. Anyway, for those of you who haven't used it, essentially it'll just load up a sound file that you have in your GMOD directory and it'll play it for you. I'm just going to quickly pop into my sounds folder Okay, so yeah, so you can see here that there's a few songs. I'm actually going to go ahead and quickly download a song because I don't want to get copyright strikes. Okay, so there you go. I've got the song. It's called Can't Forget You.mp3. Now, this can be, of course, any MP3 you want. It can also be any of the default GMOD sounds or Half-Life sounds. As long as you provide a path to that sound, it should, of course, work, okay? So now the next parameter is, do we want the sound stereo or mono? So we're actually going to make it stereo, if I can spell. Pretty stereo? I'm pretty sure that's right. Actually, you know what? Just do mono for now. Or stereo, your choice. And the next parameter is a function. Now, this function is what gets called once it's known as a station, but once the station gets created. So in this case, we're going to call it an audio source because it makes more sense. And when that happens, it passes the audio source, an error if it happened, and the error name, okay? So all we're going to do is we're going to say if the source that we was passed, what we'll do is valid, and we'll check if the source that we had is valid, because of course if it is, then we know that no error happened. Then what I'm going to do is I'm going to set the audio source variable that we made up here equal to that source variable, so we can now reference it outside of this local function that we're in. Should make sense if you've watched my previous videos, especially with things like hooks. And of course, we're actually going to go ahead and tell it to play, okay? Because if we don't tell it to play, then we're not going to actually hear any audio from it. So the first thing we're going to do is we're actually going to go ahead and I'm going to load up my game and we're going to make sure that this all works correctly. Okay, so you're going to have to excuse the jitter. As you can see there, my FPS is fine, but Bandicam has this weird issue with my computer. Let's go ahead and let's do open script, and we're going to go ahead and make sure we open the client side, of course. We're going to go ahead and open visualizer.lua. There you go. And you guys can't actually hear this. I will try and make it so that you can. But the song is actually playing right now. So what I'll do is I'll adjust my volume a little bit, and I will check to make sure you guys can hear this. Okay, so yeah, apparently you guys can hear this, which is great. But now, as you can see, our audio started playing, so that's great. So, I mean, what's the next part? Well, the next part is what we're going to do is we're going to, first of all, we're going to want to visualize our audio. So we're going to need something to draw it in. So I'm going to say hook.add. We're going to add a hood paint hook. Of course, this can be done in any draw hook. You don't even need to use a draw hook for it. Some cool visualizer. And then lastly, we'll provide the function. Now, what we're going to do here, okay, is you remember how I mentioned that we could sample multiple times across this thing, okay? Now, if we wanted to, we could sample 10 times. So we'd have a sample here, a sample here, a sample here. Now, what I mean by the number of samples is that the number of samples is essentially a table, okay? Let's say we only took 256 samples. It's only going to contain 256 pieces of data from that frequency. If we, the higher the sample we take, the more intensive it is, but the more precise we can analyze the audio, okay? Now, for most visualizers, you really don't need to really, have a really high audio resolution or whatever you would call it. But most of the time you'll be working in the bass region anyway. There's not very many visualizers that actually utilize the high end. But yeah, you definitely work in the low. So let's go ahead and let's first talk about how we actually get the frequencies, okay? So the way how we get the frequencies is, if I bring up the page here, there we go, is you can see that on an iGMOD audio channel, which conveniently enough is what our audio source is, you can call FTT and pass a table and a size, okay? And as you can see, I'm not going to go ahead and read this out to you, but essentially it samples the data to how we need it, okay? Now, you can see that the table to output the DFT magnitudes between 0, 1, and 2, blah, 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 and the sizes. Now, this is the important part because people would just type in a number here. That doesn't work. You have to specify an enum, okay? And what you'll see is if you provide this enum or the number 0, you would be taking 128 samples, okay? So this is how many samples you're essentially taking and this is the enum obviously corresponded to it. So what we're gonna do is, if I go ahead and here, what we'll do is we'll say local data is a table. Okay, now this works a bit strange to how you'd expect, but what we're gonna do is we're gonna say audio source FFT, and then we're gonna provide data like this, and we'll do FFT underscore, was it 256? Pretty sure it was 256. Let me take a look. Yeah, okay, so what we'll actually do is we'll do 512, so that means that we have 256 samples, okay? I'm not really sure why it's offset like that, but let's go ahead and do that. So what this is going to do now is every frame, it's going to go ahead and sample the audio at that current time from the audio source that we created, and whatever the data it gets, it's going to put inside this data table, okay? So you don't have to do something like data equals, because it doesn't work like that. It actually just directly puts it into the table. So anyway, now that we have this, let's actually visualize some of this audio. Okay, so what we're going to do is we're going to say for I equals 1, 256, do. So this is just going to loop over 256 times. Then what we're going to do is we're going to say draw.rounded box. Now, this probably isn't efficient, by the way. Well, I say probably. This definitely isn't efficient. But what we're going to do is we're going to go ahead and we're going to make the width 1, and we're going to make the height data, okay? No, we're going to make the height 0, sorry. And then we're going to make, sorry, these are positions. That's me being silly. We're going to make the position I. Okay, so each time we loop, it's going to move across the screen by 1 pixel. And we're going to make the Y position 0, so we start at the top of the screen. Then we're going to make the width of the X1, and we're going to make the height of the Y, whatever data I is, okay? Now, of course, doing this straight up wouldn't work. I'll go ahead and I'll make this something a bit cooler than that. We'll go like a lime color. Why not? So if we go ahead and we do this now, it is going to work, but it's not going to be very entertaining. I'll just go ahead and I'll quickly show you that, and then I'll explain why. If you've worked it out already, then good job. But if I go ahead and I open up our script now, we actually get some nice errors, but they seem to have sorted themselves out. But as you can see, it doesn't really look like anything is happening. And the reason for that is because our data, if you remember, is between 0 and 1. So the highest it could go is 1 pixel. So what we want to do is, you don't have to have it up here, but I'll create a local variable, I'll call it amp, and I'll set it to something like 250, okay? So now, if this is between 0 and 1, and we times it, and we times it by the amp, it's going to be between 0 and 250. So it's actually going to draw on our screen like it should. So if we play it now, the reason why, for those of you wondering the reason why we're getting that Lua error when I first started, it's because the audio source isn't instantly created, but we try to use it straight away. That's why it gives the error. You could, of course, put checks in there. Let's go ahead and let me just adjust my volume one more time, as it is pretty loud. Let's go ahead and do it now. And as you can see up there in the top left, it'd probably be really hard for you guys to see, but we actually have a visualizer that's working, okay? So what I'm going to do is I'm going to cancel this, and we're going to do a little bit of maths. It should be fairly easy for most of you. I'm going to times this by 3, okay? Or 4 even, okay? And I'm going to go ahead and I'm going to times our... Wait, yeah, where is it? Sorry. So this is going to put a line every 4 pixels. And then if we put a 4 here, it's going to be 4 pixels wide. And of course, by doing that, it should be much easier for you guys to see. Because it will be much bigger, of course. So if we go ahead and show you now, as you can see, you can kind of see the individual squares in there now. And you can see how they are across my screen. So if I do stop sound, we're actually going to get lots of errors if I remember. Yeah, so we're getting lots of errors because by doing stop sound, we actually destroyed this audio source. But our hood paint is still trying to use it. So, of course, you're going to want to go ahead and fix that up. But what we're going to do is we're going to raise the amp to 500 now. And we'll rerun the script. And as you can see, it's a bit more prominent. Now, frequencies change. Normally, the bass is a lot more powerful than the high end. But now that we have this, let's go ahead. Let's even go up to uh, we'll go 1,500, right? Now, we're going to do a little bit of trickery here, okay? Now, for those of you who are wondering, that's essentially a visualizer. You can end the video here if you don't wish to go any further. But as you could probably see by that, it was really jagged in the sense that they would jump in really fast. You couldn't really make a rhythm out of it. But what we can do is we can make a table, call it smooth data, before the hood paint, so it's only defined once. And while we're looping over here, we could say smooth data I is equal to lerp, and we'll lerp using something like 5 times frame time. And we're going to lerp from whatever the smooth data is over to the new data that we just sampled, okay? Now, the first thing we have to do, if you haven't worked it out already, is 256 do. We have to actually fill up smooth data with zeros, okay? Now, what we'll do is we'll put in a larger value here, like 3,000, and I'll explain why this is in a minute. Mainly because this is going to get dampened because we're actually smoothing it. And as you know, if you get a jagged line and you smooth it, generally that line gets smaller because it's been smoothed, right? So that's essentially what's happening here. And if we go ahead and we do this, what this is actually going to do is it's going to smooth them around so they don't change as instantly, as fast. And of course, by doing that, we should be able to make more of a rhythm out of it. So you can see that it is working there. If we go ahead and we change this to something like, say, 2. Let me go ahead and stop sound, and let's run this again. Okay, so it's definitely working, although it's barely noticeable there because of... Oh, wait, no, it's not working, actually. That was me being silly. The reason why it wasn't working is because here we was using data when we were supposed to be using smooth data. There we go. So, whoops. Of course, our issue was we were still using the old data. So now if we use smooth data, we should see a completely different result. There you go. As you can see, we get one solid bar. So let's go ahead and fix that. So the reason why that is happening is because we're learning from data 1. That's my fault. We're supposed to put data I there. My mistake. I do apologize. So now, as you can see, everything's a lot smoother. Now, of course, at this stage, it's probably too smooth, so we can't really make a rhythm out of it, right? But of course, we can adjust that smoothing level. We can adjust the smoothing level here, and we can make this something like 10. So now if we stop sound and we run it again, you can see that it's still smooth, but it's not as intense, okay? Now, one last thing that I just quickly want to do, and this is mainly for the guy who suggested the idea. I'm going to go ahead and I'm going to bring up a calc view. For those of you who don't know what calc view is, I'll bring the example in here for you guys to see. There you go. So essentially all it is it calculates, like you can reposition the player's camera using it, right? You can recalculate their view. Now, what we'll do is we'll leave everything as it is, just like this. And we'll go ahead and we'll only change the FOV, okay? Now, what we're going to do is we could just sample one frequency. But what we're going to do is we're going to work out an average, okay? So let's say we got 256 samples. Let's say I do for I equals 1. We'll do 50, okay? I'm going to say, before here, I'm going to say local A equals 0. A is equal to A plus smooth data I, okay? So that's going to add it on, and then eventually we're going to want to say A is equal to A divided by 50. So for those of you who don't know averaging, that's going to sample the first 50 frequencies that's on the list, and it's going to give me the average of it. So we can work out the average volume in the bass area, okay? Because, of course, let's say the kick is hitting on the band 12, but we're sampling band 9, we're not really going to get any kind of feedback from that. So we're going to sample a bunch of them, and that should give us our feedback. Then what we're going to do is we're going to say that our FOV is equal to whatever our normal FOV is plus A, okay? Because A is, of course, our amplitude. Now, we're going to want to multiply this because A is between 0 and 1 still, but we can multiply this by, say, 50, okay? Now, this might be disorientating for you. Of course, you would have to tweak this to get it how you would want it. But now, as you can see, our FOV is actually changing based on what's happening in the song. So if there's a lot of bass, which there will be a lot more of in a minute, you'll see that our FOV will go with it. So that's not actually too noticeable. What I'll do is I'll quickly do this by something like 300. This should be more than noticeable. But yeah, again, I just want to apologize for not going too in-depth with this. Like actually making something that looks really nice. I just want you to understand the concepts of it, and then you guys can come up with your own designs to make things look really cool. So as you can see, there you go. It's affecting my view a lot more. So if we just let it stop. There we go. And of course, we can do that any way we want. If I just quickly open up my sound folder. Actually, you know, I'm not going to play those. I just realized. What we'll do is we'll actually minus this instead, and we'll times it by, say, 500. So that's going to make us start zooming in. But this is pretty much it. This is the end of the video. I will show you in a second an example of what you can do with this. But you guys should be able to see the rhythm that's going on there, right? The more work you put into it, obviously, the better it's going to be. Now, what I'm going to do is, if I go into my folder for a second. Okay, there we go. I have a file called mCant Visualizer. It's an abbreviation of Monster Cat, not the drug. But yeah, essentially it's a basic visualizer that I made quite a while ago, actually. I do have to go up, I think it is, find where it plays the song. Here we go. And I got to change the name, of course, because if I don't, I will get nice copyright strikes, which nobody wants. So I'm just going to snatch it from this one. Here you go. So I'm going to set it to play this one. And what you'll see is this was my attempt. Now, this is pretty old. There is a link in the description to the GitHub page hosting this code if you need any more help on it. But this is an example of a visualizer that I made a while ago. But this is pretty much it, guys. Thanks for watching, and hopefully I'll see you in the next video. I'm shifting my mind to get around.